to day 25 of 50 days of tutelage, and in this class, I'm going to be teaching you about linear equations. In the last math class, I already introduced you to the concept of equations, unknowns, and variables. By the way, in this class, I'm going to be covering equations with one unknown and equations with two unknowns only. Now, what makes the equation linear and what makes it not linear? One of the things you have to pay attention to when you're considering whether an equation is linear or not linear is the unknown that you have there. Now, I want you to know that when I did the indices with you, I told you that anytime you have something raised to the power of 0, and if a is not 0 itself, this is going to be 1. But you can begin to have this thing raised to the power from 0, you can raise to the power of 1, you can raise to the power of 2, you can raise to the power of 3. So meaning if x represents an unknown, then x can be raised to the power of 0. You can have x raised to the power of 1. You can have x raised to the power of 2. You can have x raised to the power of 3. And it goes on and on like that. I even also talked about it when I was teaching binomial expansion. By the way, x raised to the power 0 becomes 1. X raised to the power 1 is just x. And this remains x squared. You have x raised to the power 3. And this goes on and on like that. How do you now identify which one is going to be a linear equation? The moment you have it such that everything in your equation is always comprising of only x of this power, or if it's not going to have x of this power, it's going to be a constant term. It's going to be a constant term. Whenever you have combination of such that your unknown is of power 1, and then the other terms are constant, then you have what we call a linear equation. However, this linear equation, you can also have it, that is when we're talking about one unknown. You can also have equation with two unknowns. For instance, let's say we are dealing with two unknowns, x and y. In this situation, how do you know that this equation is unknown? These are the ways. First of all, you should know that this x can be like this. You can have x squared, just like I think I've already done for the one unknown. So let me do the combination. You can have something of this nature. You can have xy. You can have x squared y, you can have xy squared. I mean, this thing can go on and on like that. I want you to know that whenever you have the combination like this, here's what I want you to know. Each of them carries their own power. In this place, x carries a power of 1, y carries a power of 1. If you combine them together, that's a power of 2. In this place, x has a power of 2, y has a power of 1. If you combine them together, that's a power of 3. So therefore, none of these will represent a linear term. All of them will be I don't want to mention what it is, but it will be a term of higher power. So they are non-linear terms. So in this case, we're going to have a linear equation that is comprising of two unknowns. That implies that the x will stand separate, the y will stand separately. They cannot be bonded together. And then lastly, you can have what? Constant revolving around them. That's basically what it is about. Now, in the last class, in the last math class, I also explained to you that if you want to solve a linear equation, for instance, now, if I give you an expression, 3x plus 5 equals 21. So when I ask you to solve for x in this place, this is quite easy. It's just basic mathematics. So what do? You can easily solve for x here by just taking 5 to the other side. So you have that 3x equals 21 minus 5. And then so that implies that 3x equals 21 minus 5, that should be 16. So 21 minus 5 is 16, which implies that x is 16 divided by 3. So it's quite easily done if you have an expression like this. But however, what if I give you that you should solve for something of this nature? 3x plus 5y equals 21. And I ask you to solve for x and y. When we have equations like this kind of equation, it will have what we call many solutions. This kind of equation will have many solutions. And in that situation, we say this guy has infinitely many solutions. Why? Because there is a lot of configuration that you can give to this that will make this guy have it. The first one here is if x equals 7. Now, I mean first one based on my own perspective. If x equals to 0 and x equals to 7 and y equals to 0, this will give us 21. This is going to give us 21. Another one is if x is, let's say for instance now, x could be What should I make x? X could be 2 and y is going to be 3. Y is going to be 3. So in that case, you have 3 times 2 is 6. 5 times 3 is 15. 15 plus 6, that's 21. So you can, I want you to even provide as many as possible combination of x and y. So in that case, you have infinitely many solutions. But however, we do not always really want that, because this equation actually represents a line, a straight line. And I'm not teaching about coordinate geometry today, so I'm not going to talk about that. So we have what we call system of equations. System of equations. And this is what most of you know as simultaneous equation. But in this case, I'm going to be doing system of linear equations. System of linear equations. Sole. Something like that. Now, what I mean by system of linear equations is that if I want to solve for a particular number of variables, one of the first criteria that I must meet is that you must have the same number of equations as the number of unknowns that you are trying to solve for. So for instance, now if I'm solving for x and y, I should have at least 2 equations. If I'm solving for x, y, and z, I should have at least 3 equations. That at least in itself is on the way to guaranteeing that we can actually find a proper solution and a unique solution for the values of the unknown. However, having two equations to solve for two unknowns does not also automatically guarantee that you would always have that in like that will always be so, that you always have a solution, a unique solution. And which leads me to the next thing I want to discuss, which is about dependent and independent equations. So now, if I give you two equations, I'm going to give you two equations from this side. So if you look at this, this is 2x plus 5y equals 6, and 3x minus 2y equals 7. And I can give you one here that says x minus y equals 4. And then this one can be, let's say, let me make this one 4y, x minus 4y equals 4. I can say this one should be, let's say, something like 3x minus 3x plus 12y equals 6. Then I can say another equation here. I can say this one is 2y minus x equals 1. Then I can say that 5x minus 10y is going to be equal to negative 5. Now, so look at these three equations that I've given you now. I want to show you something real quick. Now, there are one of these equations will not have a solution. One of these equations will have infinitely many solutions, and one of them will have a unique solution. So I'm going to start with this one down here, right here, the last one I gave, the last one. I want to show you something. If I rearrange this second part, so let me rearrange it. So that implies that the equation becomes 2y minus x equals 1. Then I want to rearrange so that y would go first. So that would be negative 10y. Then I have plus 5x equals negative 5. In this situation, another thing I can do is that what if I multiply the entire equation 1 by 5? Or sorry, by negative 5. So multiplying this by negative 5. So use that. So multiplying by negative 5, I will get negative 5 times 2, that's negative 10y. Negative 5 times negative x, that's positive 5x. And this will be negative 5 times negative 1. So that's what? Negative 5. So what does that imply? That implies that this second equation is just similar to the first equation. They are the same thing. It's just that one is in the reduced form and one is in the compounded form. So therefore, when you have simultaneous equations that are like this, it is also almost the same thing as you having that thing I said earlier, having one equation to solve for two unknown. So in that case, you have infinitely many solutions. So this kind of system, they are dependent on each other. They are dependent on each other. So it's a dependent kind of equation, system of equations. So the system is dependent. Now let's go to this one. This one right here. So I have x minus 4y equals 4. Then I have negative 3x plus 12y, that equals 6. Now, so the same thing we did. All we just have to do is that we want to try to, first of all, rearrange them. Let x follow x, let y follow y. And we want to try to make at least one of the variables have the same coefficient, just like I did here. I just multiplied by negative 5 to make sure that this one also have negative 10. So in this case now, I can multiply this by negative 3 so that it has the same variable, the same coefficient as that of x in the second equation. So if I do that, that's going to be negative 3x. So negative 3 times negative 4, that's plus 12y. And then negative 3 times 4, that's negative 12. Now this is repeated. So we have negative 3x plus 12y equals 6. Now if you notice now, this wants to look similar to what happened here. But the difference is that these two are now the same. But the result that they gave is not the same. It's not possible that you have these two equations in a system and then they are both equal to different things. That implies that there will be no solution in this situation. You cannot have a set of two values, that is a set of two values x and y, such that both of them will satisfy these two equations simultaneously. So therefore, this system is a system with no solution, a system with no solution. And so that's that. Now, finally, this one, if you try to do it in the same way, let me just put it down here. So if you try to do this the same way, so it's already well arranged. So I'm trying to make the first one look like the second one. Obviously, you can see that this one cannot actually look like the other. I give you as an assignment. You can actually do that on your own. Check if this system, they are dependent or there will be no solution. But anyways, which leads me to the way we solve system of linear equations. I'm going to be teaching you two methods in this particular video. The two methods are going to be the substitution method and the elimination method. The substitution method and the elimination method. So let's see how that goes. So here, to use the substitution method, what exactly is it about? What you need to do is that you need to pick one of the equations. So pick one of the equations. So let's say this is equation 1 and this is equation 2. So you pick one of the equations. So for instance, now I want to pick the second equation. So I'm picking equation 2. So 3x minus 2y equals 7. The next thing I'm going to do, you should be taking notes and be taking down all these steps I'm giving you one after the other. The next thing you want to do is that make one of the unknowns, make it the subject of formula there. So if it is x, I want to make subject of formula. That implies that in this place, 3x is going to be 7 plus 2y. So what's happening is that negative 2y is going to the right hand side. So you have 7 plus 2y. And finally, to make this other one, now to let x stand alone here, I'll divide both sides by 3. So therefore, x equals 7 plus 2y divided by 3. Now I'm done with the first stage. The next stage now is to substitute. So I will now substitute this value of x. Anywhere I see x in the first equation, that is the other equation, I'm going to replace it with the expression 7 plus 2y over 3. So therefore, the equation 1 becomes 2 multiplied by, so instead of x, I have 7 plus 2y divided by 3 plus 5y equals 6. Now, I can decide to, expand and all of those things. So one first thing you should do is that whenever you're dealing with equations like this and you have denominator at the bottom like this, you can always multiply through by that denominator. That is, multiply everything. Multiply this by 3, multiply this by 3, and multiply this by 3. By the way, if you don't have an equation, you won't be able to do that because you cannot just multiply an expression through by a number. You have changed that particular expression. But because it's an equation, it's balanced both on the left hand side and the right hand side. So this 3 goes away, and then you have 2 multiplied by 7 plus 2y left. Then you have 3 times 5, that's 15y, and 6 times 3, that is 18. So there you can now open the parentheses. Now 2 times 7 is 14, 2 times 2 is 4y, plus 15y equals 18. So therefore, you are going to have that 4y plus 15y, that is 19y, equals 18 minus 14. So that implies that 19y equals, what's 18 minus 14? 4. And you divide both sides by 19, so that will be 4 divided by 19. So with this now, we've been able to solve for y. Therefore, x will now be 7 plus 2. Now you've solved for y already, so that's 4 over 19, everything divided by 3. and that will be 7 plus 8 divided by 19, everything divided by 3. And so if you do this very well, we've talked about fraction already, so you should be able to do the appropriate thing here. 7 plus 8 over 19, that's 141 over 19. So if you divide that by 3, you're going to have 47 divided by 19. And with that, that is how the substitution method goes. It goes like that. Now, let us talk about the elimination method. Let's talk about the elimination method. So I'm just going to paste the same equation right here. So how do we use the elimination method? This is the way we go about it. We want to actually eliminate one of the unknowns, and then we want to solve for one of the other one. So to do that, the first step is to make sure that in the two equations, the unknown, they have the same coefficient. As you can see here, if I choose x to eliminate, x, the coefficient of x here is 2, and the coefficient of x here is 3. So therefore, I want to find a way to make them the same. So I want to show you something. If let's say the coefficients were 2 and 4, to make them the same, the only thing I have to do is to multiply this one by 2. That's so straightforward. But in this case, they are not the same. Another thing is that, let's say one is, you have one to be, let's say, 4, and you have the other one to be what? 6. To make them the same, I'll just look for a number that I can use to multiply one of them and another number to multiply the other, and they will quickly give me the nearest, closest number. I can multiply this one by 3, and I can multiply this one by 2, and that will give me 12 and 12. But in this situation, I don't have such number that I can, maybe different number. So instead of me wasting my time, what I can do is that I can just switch the multiplication. What I would do is that I can multiply 2 by 3, and I can multiply 3 by 2, and they will both give me 6. So having that now, but here's the thing, I've only used the x unknown to do the judging of both. But whatever I'm doing for any of the term here, I'm going to do it throughout the entire thing. So therefore, I'm going to multiply this whole thing by 3 to make this 2 6. And I'm going to multiply this entire thing by 2 to make this 3 6. So let's go. 3 times 2 is 6x, plus 3 times 5 is 15y. Then 3 times 6, that's going to be 18. Then we have 2 times 3 is 6x. Negative 2 times 2, that's negative 4y. 7 times 2, that's 14. So when you're done with this now, the next step is to either sum or subtract the two equations. So what determines whether you will sum or subtract them? Look at the signs that both of them carry. This one has a positive sign, this one has a positive sign. Whenever they have the same sign, what you're going to do is subtract. So, like I said, whenever they have the same sign, what you're going to do is subtract. So and if they have different signs, like let's say they have different signs, if one has a negative sign and one has a positive sign, what you're going to do is add. So in this place, I'm going to subtract the two equations from each other. So that's going to be 6x minus 6x. Now, plus 15y minus, that is the subtraction I'm doing. But what's the number itself? Negative 4y. And that will be 18 minus 14. So in this place, this will become 0. This will now be 15y plus 4y. And that will be equal to 4. And that implies that 19y equals 4. And that implies that y equals 4 divided by 19. And if you look at that, it tallies with the same result that we got for y earlier. And after doing that, once you have gotten the value for y, then you can substitute back into any of the equation and you solve for your x, just like I have done in the previous method. And that's how you solve these equations. There are other two methods that we use to solve this system of linear equations. We have the matrix method and we have the graphical method. But in this video, I'm not going to be teaching you that. If you've learned something in this class, just make sure that you subscribe, you like, and you share the video with your friends as well. I'm going to see you in the next one.